Hello. Today, we'll learn about a useful process in algebra called rationalizing a fraction. Rationalizing a fraction means getting rid of any irrational numbers like square roots from the denominator of the fraction. The main goal is to rewrite the fraction so that the bottom part, the denominator, is a nice clean rational number. But why do we need to do this? Firstly, it often makes the expression simpler and easier to work with in further calculations. Secondly, it's a standard way to present answers in mathematics, making them look consistent and tidy. Let's look at the first case, when the denominator is a single square root, often called a surd. Consider the fraction 1 over the square root of 2. Notice the denominator, square root of 2, is an irrational number. To rationalize this, we multiply both the numerator and the denominator by the square root of 2. This is like multiplying by 1, so we don't change the value of the fraction. In the numerator, 1 times the square root of 2 is just the square root of 2. In the denominator, the square root of 2 times the square root of 2 is simply 2. So, the rationalized fraction is the square root of 2 over 2. See, the denominator is now the rational number 2. Now for the second case, the denominator is a binomial involving a square root. For example, consider 1 over 1 plus the square root of 3. Again, the denominator contains an irrational number. To rationalize this, we use something called the conjugate. The conjugate of a binomial, like a plus the square root of b, is a minus the square root of b. So, the conjugate of 1 plus the square root of 3 is 1 minus the square root of 3. We multiply the numerator and denominator by this conjugate. So, we multiply by 1 minus the square root of 3 over 1 minus the square root of 3. The numerator becomes 1 times 1 minus the square root of 3, which is just 1 minus the square root of 3. For the denominator, we multiply 1 plus the square root of 3 by 1 minus the square root of 3. This uses the difference of squares pattern. A plus b, ab, equals a squared minus b squared. Here, a is 1 and b is the square root of 3. So the denominator becomes 1 squared minus the square root of 3 squared, which is 1 minus 3 equaling negative 2. Putting it together, the rationalized fraction is 1 minus the square root of 3 all over negative 2. The denominator, negative 2, is rational. Here's a quick summary table of the two cases we covered. If the denominator is the square root of multiply by the square root of over the square root of a to get the square root of over a. If the denominator is a plus the square root of b, multiply by its conjugate, a minus the square root of b over a minus the square root of b, to get a minus the square root of b over a squared minus b. So, in simple words, rationalizing a fraction just means changing it so there are no square roots left in the denominator. You do this by multiplying the top and bottom by whatever is needed to clear out that root from the bottom. I hope this explanation helped you understand how to rationalize fractions. If you have any specific examples or need more details, feel free to ask. In this video, we'll simplify a mathematical expression involving square roots. Our goal is to write the expression fraction 16 plus 11 root 10 divided by 2 plus root 10 plus 1 in the form p plus q root 10, where p and q are integers. Let's first focus on simplifying the fraction part of the expression, 16 plus 11 root 10 divided by 2 plus root 10. To simplify this fraction, we need to rationalize the denominator. The denominator is 2 plus the square root of 10. To rationalize it, we multiply both the numerator and the denominator by the conjugate of the denominator. The conjugate of 2 plus root 10 is 2 minus root 10. So, we multiply the fraction by 2 minus root 10 over 2 minus root 10. Now, let's expand the numerator. We multiply 16 plus 11 root 10 by 2 minus root 10. Using the distributive property or FOIL method, 16 times 2 is 32. 16 times negative root 10 is negative 16 root 10. 11 root 10 times 2 is positive 22 root 10. And 11 root 10 times negative root 10 is negative 11 times 10, which is negative 110. Combining the constant terms and the root 10 terms, 32 minus 110 is negative 78. Negative 16 root 10 plus 22 root 10 is positive 6 root 10. So the numerator simplifies to negative 78 plus 6 root 10. Next, let's expand the denominator. We multiply 2 plus root 10 by 2 minus root 10. This is a difference of squares. A plus b, ab, equals a squared minus b squared. So we have 2 squared minus root 10 squared, which is 4 minus 10 equaling negative 6. Now we can rewrite the fraction with the simplified numerator and denominator, negative 78 plus 6 root 10, all divided by negative 6. We can divide each term in the numerator by negative 6. Negative 78 divided by negative 6 is positive 13. Positive 6 root 10 divided by negative 6 is negative root 10. So the fraction simplifies to 13 minus root 10. Now, let's not forget the plus 1 from the original expression. We add 1 to our simplified fraction result. Combining the constant terms, 13 plus 1 is 14. So the final expression simplifies to 14 minus root 10. The problem asks for the answer in the form p plus q root 10. Comparing 14 minus root 10 to p plus q root 10, we can see that p is 14. And since minus root 10 is the same as minus 1 times root 10, q is negative 1. Both 14 and negative 1 are integers as required. So, by rationalizing the denominator and simplifying, we have successfully written the expression in the required form.